Hi everyone, today is Friday, it's 28th of January and it is 2 p.m. So this means that it is time to start our Friday forecasting talks. And today we will have a talk by Johann Robette on the topic of bridging the gap between forecast and business value. Johann works in VK and he will say something about himself and his work later. But I wanted to start, by the way, my name is Johann. I work for the Center for Marketing Analytics and Forecasting. And I typically lead these events. And as usual, I wanted to start by saying a couple of words about the center, what we do and so on. So this is the slide I typically show with the old group that we have. Currently it's 9 of us, but we are hoping to expand, waiting if there will be an opening in our department, hoping for that. We provide a variety of services, including consultancy, software development. One of those that might be interesting to some of companies is master summer projects, where a student would go and solve a specific problem and find a specific answer to a question by the company. And we have expertise in a variety of areas, including supply chain, forecasting, marketing analytics, forecasting and planning, and machine learning. So if you're interested in working with us, please get in touch with us, either via Twitter. You can follow us, there we publish the main events and repost the most interesting things by our colleagues. LinkedIn, email if you want to send us an email. We also have our website on the Lancaster webpage, and we have our YouTube where we publish videos from different events. So stay tuned, keep in touch if you want to. And now it is time to go to the main presentation today. Johann, please unmute yourself and share your screen.
Yep. So good afternoon, everyone. I should say welcome home. I'm really happy to be here with you today. Really, thanks a lot for having me. I've been watching almost every episode of this series so far, so I can say that I'm a big fan. So it's really a great pleasure to now be part of it. As you've probably already guessed, I'm not English, I'm not American, but I have this lovely French accent, and indeed I'm French. I'm living in the north of France, and I work for a French company which is called Vecchia. In short, Vecchia is a software company. We offer a SaaS solution that's dedicated to demand planning, to inventory optimization, and to replenishment automation. And to be even more precise than that, I should say probabilistic demand planning, economic inventory optimization, because it makes a big difference. It's all about making decisions that really make sense, that consider, that embrace the uncertainty, and that at the end are really profitable to our customers. We are present in quite a few industries so far, in retail, in the automotive industry, in the energy, telco, pharmaceuticals, and maybe a few other field services as well. We partner both with small and medium-sized businesses, but we also work with very large companies, such as Orange, for example, in the telco industry, or Engie in the energy industry. Both are part of the Fortune 500 ranking, so pretty big companies. At Vecchia, I'm in charge of customer success management. So in short, my role is to ensure that we deliver on our promises and that we even deliver more than that, but also that our customers are well aware of the value and of the savings they're getting from us. And this directly leads us to today's topic, which is bridging the gap between forecast and business value. So just forgetting to move the slide, so here's the logo of Vecchia for sure. So the short promises for today, this presentation will be thought-provoking. So you are informed, be ready. Let's go then. Forecasting is quite often compared to archery. We've all seen over and over again these illustrations where that are used to describe forecasting. The aim is the center of the target, which represents what forecasters are trying to predict. And the more precise, the more accurate their forecast, the closer the arrow gets to the center of the target. It's a very common way of illustrating forecasting activities. We might not all have practiced archery in the real world, but most of us have for sure, at least once in our lives, played darts. Do you know what one of the most important differences between these two sports is, between archery and between darts? Of course, there are many differences that we can think of, but what would make a good archer, let's say Robin Hood, what would make Robin Hood a pretty bad darts player? The main difference I'm referring to is the scoring system. If we look closely at these two games boards, we see that they are slightly different one from each other. This basically means that you don't win at archery the way you win at darts. In both games, there might be some variations, but in both games, the aim is the exact same, to get the highest possible score by hitting the target. But the way to score is different. To be successful in archery, you have to aim for the center of the target, which is called the bull's eye. This is the most rewarding area of the board, and the further away you get from it, the less rewarding it is. But you can see that it makes no difference whether you hit above or below or to the left or to the right of the bullseye. What matters is the distance from the center, nothing else. With darts, it's completely different. The board is divided into different zones, different areas, all of which offers different rewards. Like archery, the center of the target is a highly rewarding area, but there are other areas that are even more rewarding than that. Unfortunately, these are really small, and even more important, they are close to low rewarding areas. So unless you are an exceptional darts player, which means unless you always perform perfectly, you're always really accurate and precise, it's a pretty bad idea to aim for these highly rewarding areas. In fact, in darts, depending on your skill level, so which is your accuracy and your precision, you should aim for specific areas to maximize your probability of reward. For example, if you look at the southwest quadrant of the dartboard, you can get the numbers 16, 7, and 19 together. This is a very interesting area. If your accuracy and your precision are limited, this is an ideal area to aim for. Because even if you're not accurate, you shouldn't get a bad result out of this zone. Personally, I always aim for the 7. I know I'm not good at darts, and I know I won't hit the 7, but there are high chances I would get 16 or 19 instead, and it works pretty well. So for those interested in this topic, the topic of statistics in darts, there are some very interesting articles that have been published by a young statistician from Stanford University that discuss this specific point. You just have to Google a statistician plays darts, and you'll find these resources. Really interesting. Anyway, I'm sure you now understand the fundamental difference between these two games, which is the scoring system. Aiming for the center of the target is not necessarily the best strategy. It all depends on the scoring system. So let's leave these games aside for the moment. We'll come back to them later on. Okay, now let's deep dive into a very hot topic, something that so many people are interested in, but also something that is far from being cracked yet. I'm referring to value added, forecast monetization, forecast dollarization, whatever you call this. The key question we are trying to answer here is how to translate, how to turn a forecast performance into an economic improvement, how to assess the link between a forecast and its effective business value. This is clearly a topic I'm really passionate about. As a customer success manager at Vecchia, one of my key missions is to demonstrate, to highlight the value that our customer get from our solution. And as you probably know from your own experience, senior executives, financial managers, they are not happy with pure forecast accuracy metrics. They want to have it expressed in monetary value, in euros, in dollars. And clearly, and that might be a bit shocking to some of you because you are forecasting experts, but like these senior executives, I personally don't care about how a forecast is created or what is his level of accuracy or whatever. Others do, you do, and that's great. But personally, I don't care. My only perspective is, does a forecast allow for the right decision to be made? Does it generate value or not? Value could take different forms, economic, social, environmental, but how much value is generated? That's my only interest. So how do we assess the quality of our forecast so far? How have we done it for decades? Well, it all boils down to forecast accuracy, and forecast accuracy. We're not going to deep dive into the different metrics that exist. There are a lot, but let's just sum it this way. In forecasting, the norm is to assess the quality of the forecast using accuracy metrics. Okay. And then based on these metrics, how do we know if we are doing a good job or a poor job? How do we know if we are really adding value? Well, typically there are two main methods for this. First of all, an approach I'm really fond of is the one called forecast value added, or FVA. This is a very simple but powerful approach, which essentially consists in evaluating the gain in forecast accuracy between different models or between different steps in a process. It usually starts with the accuracy achieved by a naive forecasting method, such as a random walk or seasonal random walk, or even more advanced methods. And then this accuracy is compared to the one achieved by another method. If there's a gain, the method improved on the previous one. If there's a lot, it does not, basically. This is a very, very interesting approach, and I think we are all familiar with it. But yet, if some of us are not yet really, I highly recommend reading the book, The Business Forecasting Deal by Michael Gilliland, which describes this approach in detail. Yet, although I love this approach, it suffers from an important limitation. And to be honest, the FVA approach is not the problem. The problem is that it's generally applied to forecast accuracy metrics. In fact, it's called forecast value added, but it measures forecast accuracy added. And as long as accuracy metrics are used, there's nothing like value in there. Unless, of course, you subscribe to the assumption, the very common assumption, that accuracy and value are linked together, are correlated. And we'll come back to this in a few seconds. There is a second classic way of estimating the value of a forecast from an economic point of view, and this is called benchmarks. Some organizations provide benchmarks for free or commercially, and these benchmarks describe the performance achieved by different companies in different industries. And based on these benchmarks, some have established that 1% increase in forecast accuracy, and you can note that here, once again, forecast accuracy is the core metric. A 1% increase in forecast accuracy has X, Y, and Z impacts on various KPIs. So the use of such a benchmark seems very interesting. It seems so easy to translate an improvement in accuracy into an economic benefit. But as it's been pointed out in many publications, this approach suffers from massive limitations. Industries are not equal. Within the same industries, companies are not equal. They don't have the same strategy, for example. Even within the same company, products are not equal. For a specific product, markets are not equal. For a specific market, customers are not equal. So we basically cannot take one figure from such a benchmark and apply it to another context. The conclusion will be totally wrong and misleading. Figures are right in the context where they've been measured, and that's almost all. In fact, regardless of which of those two methods is used, forecast value added or benchmarks, most attempts to translate forecast performance into economic performance rely on forecast accuracy. So it all comes down to the assumption that the more accurate the forecast, the better the decision. And then that the better the decision, the better the economic performance. This is absolutely true. It's common sense. Yet, this is wrong when applied to forecast accuracy. This is wrong when applied to forecast accuracy. I know it really sounds counterintuitive, and you have really the right to feel skeptical about this at this stage. In fact, this sounds so counterintuitive that we decided a few months ago to conduct a large-scale experiment to establish whether or not forecast accuracy metrics are good indicators or bad indicators of economic performance. If they are, great, that's perfect. We could all, and I would even say we should all keep building intensively on these metrics. But if they are not, damn Houston, we have a problem. It would essentially mean that we have somehow built on sand. It would mean that for decades we've been optimizing our forecast against metrics that were misleading. So what does this experiment look like? Well, it's a very simple approach. We applied it to the context of inventory optimization because this is what we do at Vikia. So we naturally chose this use case first. This means, and this is a key point, and it's an important disclaimer, this means that our whole experimentation has focused on short-term operational forecast only, and that our findings apply to this specific use case. Of course, it could have been applied to many other contexts, to other types of forecasts, but it has not been done. So it's still an open field of research and of experimentation. Our whole experimentation is based on what I would call a cost-oriented digital twin. This digital twin is nothing more than an algorithm that has two main steps. The first steps implement an inventory management policy. So based on an input forecast, this policy decides if a replenishment is required or not, and it decides how much inventory should be sent. And the second step evaluates the costs of this replenishment decision. Lost sales costs, holding costs, fixed costs. So this is the basic tool we use to evaluate the performance of a forecast. And by feeding this digital twin with different forecasts, we can assess the economic cost of each of them. And we can then compare this cost to the forecast accuracy of the different forecasts and estimate the relationship between those. Of course, we wanted to build our experiment on a real use case, and we also wanted to do it at scale so that the conclusion would be really meaningful. And this is why we turned to the M5 competition dataset. As you probably know, the M5 competition is a forecasting competition that ran in 2020, 2021. And what's really great here is that thanks to this competition, we have the unique opportunity to analyze not one or two, but 74 different forecasts that have been generated for the very same scope. So we have 10 shops, more than 3,000 items, 28 days. And for each shop, item, and day, we have 74 different forecasts available. So this is a unique opportunity. So we fed our digital twin with those 74 different forecasts. This means we calculated literally millions of replenishment decisions, and for each one we computed the associated costs. And this allowed us to compare costs against various forecast accuracy metrics and to measure the relationship, the correlation between these. And to take it even a step further, we have even calculated this correlation at different levels of aggregation, from the top full perimeter level down to the most granular store item level. And this is what we obtained. This graph shows the correlation we obtained for different metrics, different colors on the graph, and different levels. And what's important here is that at the most granular level, at the store item level, at the level at which the replenishment decision has to be made, so here on the right of the screen, and more or less regardless of the accuracy metric being used, we obtain an average correlation of 25%. 25% correlation between forecast accuracy and cost. Only 25%, I should say. Of course, this is not a good news. This is a major concern. It means that forecast accuracy metrics and costs are, in this experiment, weakly correlated. This means that you can improve your forecast accuracy by 5%, for example, which is supposed to be a great achievement, and at the same time lose money. And the opposite is also true. It means you could reduce your forecast accuracy by 5%, which is supposed to be really bad. You'll be blamed for that. And because of this, the company will increase its profits. This means that the common assumption, the better the forecast accuracy, the better the performance, is wrong. So once again, this all sounds totally counterintuitive. I know it does, and yet this is what we got from the experiment. So let's get back to basics. Bad forecasting will always lead to bad decisions, and bad decision will in turn always lead to bad performance. Let's be clear, the study does not say otherwise. What this study says, though, is that forecast accuracy metrics are great metrics, but they measure the quality of a forecast only from a purely mathematical point of view. They do not measure the quality of a forecast from a value perspective. And those are two totally different perspectives. This is what the study said. How is it possible then? Well, we introduced this presentation by discussing the main difference between archery and darts. And if you remember, the answer was the scoring system. It's the exact same here. We are optimizing our forecast against a specific forecast accuracy metric, which is here our archery scoring system. But the business scoring system is totally different. it's way more complex, like the dot scoring system. And aiming for the center of the target, aiming to predict as accurately as possible the demand, might not be the best strategy. And it's very easy to demonstrate, by the way. Let's take an example, a very simplistic example. Imagine a product that you sold $10 per unit with a lifespan of, let's say, 1 week. We have a 50% gross margin to make calculation easier. So the purchase price is $5 and the gross margin is $5 per unit sold. Let's draw some graphs, basic graphs, to make the link between forecast and cost really visible. So here on the horizontal axis, we have the forecast demand. And then here, this vertical line in the middle is the demand we try to forecast, the real demand. Of course, unless we forecast demand perfectly, we are faced with an error. Most forecast accuracy metrics consider the absolute error. In doing so, we basically ignore whether we are above or below the real demand. They are symmetrical. Okay, so the forecast error looks like this. But for sure, even if being 10 units above or 10 units below the demand results in the same forecast error, we don't make the same decisions based on this forecast, and we don't anchor the same cost. That's obvious. So to make it really simple, let's say our replenishment quantity, so the policy we applied, the replenishment quantity equals the forecast quantity. It's a very silly policy, but if we forecasted 8, we would have replenished 8. In reality, it's much more complex. We may have stocks already in place. We may have deliveries in progress. We have different pack sizes, different prices based on the volume that is ordered. We may have safety stocks, minimum order quantities, etc. All of this makes the replenishment decisions much more complex than this. But here, let's just assume the simplest possible case, where the replenishment quantity equals the forecast. So we have something like this. And what about cost now? Here there are multiple cases. As long as we don't have enough inventory to fulfill the demand, we are losing sales. The cost associated to a shortage could include things that are pretty hard to estimate, such as a poor customer experience, a loss in reputation, the loss of an entire shopping cart, for example in e-com, because of one single missing item. The cost of initiating emergency actions to serve the customer anyway. But here, let's just assume that we only lose our margin, which is, as we defined it in the beginning, 50% of the product cost, so $5 per lost sale. Then, as soon as the inventory exceeds the real demand, we start paying holding costs. So let's say 20% per year. It's a benchmark. So 0.4% of the purchase price per week. This is, in our example, 20 cents per unit and per week. As you can see, holding a small amount of excess stock is, in this example at least, nothing compared to the cost of missing a sale. But of course, as soon as the excess inventory exceeds the demand over the lifespan of the product, we will face obsolescence. This means the product will certainly be discounted or worse disposed, depending on its salvage value or its salvage cost. And here it's a total loss in capital, so we are losing $5 per unit. So we clearly see that the cost of being short of product or the cost of being in excess are not symmetrical at all, as opposed to the forecast accuracy. Also, the link between forecast accuracy and cost is far from being straight and obvious. And still here, as we said, it's a simplistic case. It's even more complex if we add volume discounts, packaging constraints, minimum order quantities, etc. Let's pick two different forecasts here, A and B. As you can see, although forecast A is clearly more accurate than forecast B, it's at the end much more expensive in terms of cost. If a company had changed its forecast from B to A, all the accuracy metric lights would be green. Congratulations, let's open a bottle of champagne. Yet, because of this so-called improvement, the company will in fact increase its cost and then lose money. So if we try to sum up what we said so far, I would put it this way. For decades, we forecasters have been trained to be the best possible archers. We do our best to hit the middle of our archery target to be accurate. And we evaluate the quality of our forecast through the prism of the error we made, the distance between our arrow and the center of the target. But in the business world, we are not engaged in an archery competition, but in a darts competition. The scoring system is totally different because of our decision process and because of the structure of cost. So the way we evaluate our forecast should be different. We need to adjust our views, to adapt our metrics so they now focus on how our forecasts perform for real in the real world. Yet, after all, at this stage, one could ask, is it worth the hassle? Well, as usual, it depends on the return on investment. There are so many things that should and could be improved in companies that we have to make choices. We have to pick up really the topics we want to focus on and just basically discard the others. And let's be honest, we don't care about saving a few cents. But if changing the rules of the game does more than that, more than a few cents, if it has a large impact on business performance, then for sure it may be worth challenging some of our good old standards. Our experimentation clearly showed that the best forecasts, according to a specific metrics, were not the best ones anymore if another metric was considered. For example, the forecast that came second in the M5 competition rankings, so according to the forecast accuracy metric they used, would have been ranked 45th according to its effective cost. So to kind of estimate the potential savings, this is what we did. We picked up the top 5 forecasts according to each metric, including here a cost-oriented metric of our own. And then for each of these top 5 forecasts, we computed their average costs, and we obtained the results here on this slide. Picking up forecasts according to a metric that consider the costs, of the decisions that have been made, allow for 10% to 35% savings on replenishment costs. This is a really significant impact. This represents millions of dollars of savings a year for a standard retailer. So this clearly leads us to the conclusion that it is worth challenging and reviewing some of our good old practices. I won't have time to share more about this specific point just right now, but if you'd like to get more details about it, I recommend giving a read to some of our articles that are available on LinkedIn or Medium. More specifically, I suggest the one entitled The First Will Be Last and the Last First. You get the reference. And it contains more details about the experiment and the conclusions. And now, where do we go from here? Am I advocating that we stop considering accuracy as an important metric? I've been a few times criticized for being part of an anti-accuracy crowd. Well, which is absolutely false. I'm not anti-accuracy at all, but for sure, I'm not in favor of focusing exclusively on forecast accuracy metrics. Those metrics are not sufficient. We need to consider more data if we want to make better decisions. Will it make our activities more complex then? Yeah, I think so, of course. Accounting for more data, doing more analysis will by definition add some work. Is digital twin, like the one we use in our experiment, the only answer to this challenge? Here, I don't know. I just don't know. There might be other solutions. There might be simpler solutions. Once again, this is really an open field of research, but for sure, we know 2 things. We know that it's worth challenging the status quo, and we know that at this stage, a digital twin is at least one answer. It might not be the only answer, it might add some complexity, but it's at least an answer to this challenge. Now, what I personally appreciate, what's really interesting about using a digital twin is that it offers capabilities that go far beyond the topic we just discussed. Such a tool offers capabilities that clearly open up new perspectives in forecasting and that unlocks some of the barriers we've been facing for decades. For example, let's go back to one of our very first questions, how to evaluate the performance of a forecasting team, but from a business perspective. Well, if we feed our digital twin with the actual forecast, the forecast produced by the demand planners, we could estimate the costs triggered by this forecast. Okay. If we then feed the same digital twin with a naive forecast, we estimate the cost that you would have faced if we didn't have a forecasting team. The difference between these two costs is the savings made by the forecasting team. In fact, this is nothing more than the forecast value-added approach we discussed earlier, but it's here applied to costs instead of accuracy, to really estimate the real value that have been added. And you basically can't estimate such an added value without a form or another of digital twin. Because to conduct such an analysis, you have to model the decision process, to know your cost structure, and to be able to simulate different scenarios based on the different forecasts. And then at last, without playing any guessing games, you are able to accurately quantify the value added by the forecasting team. And the exact same approach could be applied to other use cases. For example, imagine you are to invest in a new forecasting solution. You are reviewing proposals of different vendors and you're not quite sure about which solution would be best for you. Some solutions have demonstrated a better accuracy than others. Some solutions are cheaper than others. Some solutions are faster to implement than others. But which one, if any, is the good choice for your company? It's quite difficult from the customer's point of view to identify who could really help, to identify which solution is the most appropriate for a specific context. I think we've all heard of companies that have invested hundreds of thousands of dollars, if not millions, in solutions that have shown no improvement afterwards, despite initial promises. But here again, by feeding a digital twin with the current forecast and then with the forecast generated by different vendors, we are now able to see which vendors are truly delivering value and whether this added value is worth investing in their solution. This is really a must-have capability to mitigate risk before committing a company to a major project. It's even hard to imagine that companies are still in 2022 accepting to make any investment on a forecasting solution without any clue on the effective value this solution would deliver. Anyway, but there's still a totally different use for a digital twin, something that goes far beyond what we are used to and that provides information we've never looked at before. Up to now, we've mostly tried to use the digital twin to compare the performance of different forecasts and to calculate the added value. But what's the cost of inaccuracy? How much value does a forecast leave on the table? How much value is still left to be captured by improving the performance of a forecast? If you were asked what's the ultimate forecast accuracy we can dream of, well, it's 100% accuracy. Whatever the skew, whatever the cost, whatever the location, the answer is 100%. There's no shade of gray here, no nuance. So this kind of answer is useless, right? It does not provide any relevant information. You're not learning anything about your portfolio of products and sites. But a digital twin could give more useful answers. What would we get if we fed our digital twin with what we call at Vetia the oracle forecast, which is the ground truth, the true demand signal? We would then estimate the cost we would have faced if we had forecast the future perfectly. If we had known the demand in advance, if we had a crystal ball, this is the cost of the decisions we would have made. And that by comparing this cost, which by the way is not necessarily zero because of constraints such as minimum order quantity, pack sizes, etc. By comparing this minimum cost with the actual forecast cost, we are then able to determine precisely the value that is still to be gained. For sure, we'll never know the future in advance, and we'll never be able to predict things perfectly. But with this information, we can now take a different look at our portfolio of products and sites. It's as if we've just started wearing, X-ray glasses. We now see the invisible. We see the value that's still there, ungrabbed for us. We are able to map the remaining value in our portfolio. A value map, that's it. That's what we have, a value map. And this enables us to prioritize more efficiently our activities. We are, for example, able to spot perimeters where there's still a lot of value to be captured and which were not identified as such. until now because they were not necessarily included in the 2080 or in any ABC XYZ classification. We are also able to identify perimeter where the value to be gained is pretty low. And yet, because the forecast accuracy was also pretty low, it would still have attracted a lot of attention, a lot of time and resources. But now we see that these perimeters do not deserve any additional work. We are even able to identify areas where a naive forecast alone, no matter how accurate it is sufficient to capture all the potential value. So definitely such a value map, such a cost-oriented digital twin, they are really fantastic assets for any company. They provide information we have been waiting for, information we have been asked for, and even information we did not dare to dream of. And there are even more use cases, but unfortunately, I'm pretty sure we are already running out of time. So as we've already published a few articles covering these articles, really feel free to ping me on LinkedIn, and I'll be happy to share them with you. Maybe just one last word. As I said earlier, this is a very promising area of research. And as such, we're launching a call for collaboration. We're looking for companies, whatever the industry, whatever the size, that are willing to join in this research and to test such a capability. So it's a really great opportunity to learn and to improve your practices and to eventually close the gap between forecast and business value. So if you are interested, just contact me by email or ping me on LinkedIn. It's that easy, and we'll define together the best way we could partner on this. I think time's up for now. Hope you enjoyed this presentation. Hope it was, as I promised, a bit thought-provoking. So now let's discuss this point, because for sure this raises a lot of questions. Thanks a lot.
Thank you very much, Johann. So I think that it was indeed a fascinating and thought-provoking presentation. And I've also asked John Boylan, the director of our center, to come up with some comments and maybe some questions. So John, over to you.
Thank you, Ivan. Just make sure, can you hear me?
Yes, we can hear you well.
That's good. Okay. Well, let me just repeat what Ivan said. Thank you very much, Johann, for a really interesting talk. I was going to say that you've addressed an important issue, but maybe we should say you're addressing the important issue in business forecasting, actually. And of course, it's a very challenging one. So I think we can all agree that it's business value that matters primarily, rather than forecast accuracy. That's clear. Can you tell us a little bit more about how you go about measuring business value? You gave us the example of inventory, but obviously there are other reasons why forecasts are generated. They could be generated to decide about promotions or discounts, for example, in marketing, or maybe capacity planning, things like this. There's different contexts. So I suppose my main question is, can you use the approach that you've been suggesting for other areas of application as well?
Thanks a lot for raising this question. It's an important question. It's also the opportunity to come back to a very important point. So far, all the conclusions I showed and all the presentation was really focused on inventory optimization for retail stores, so short-term operational forecast. It could have been applied to other types of forecasts. You mentioned promotions planning, capacity planning, or any other type, but we did not yet. And really, to be honest, I'm not an expert on those specific forecasts. At VK, our only expertise is on probabilistic inventory optimization and replenishment automation. So it's already a tough topic to address. So I'm humble enough to say that I don't know.
Okay.
Well, I mean, certainly on these other types of forecasts, but yet the approach that has been designed to be generic enough to be applied to different forecasts. There are just two steps. First, we have to model the decision process. So it means that this decision process should be well understood so that it could be simulated. So that's the first requirement. And second, the cost structure should be understood. And the goal here is really also to automate the evaluation of the cost decisions. So the approach could be applied to any context. And then we have two cases. There are cases where indeed, the process is well defined and could be automated and so on. So here, a digital twin definitely makes sense because you can implement this and simulate and automate this kind of analysis. And there are all the types of forecasts that rely on human expertise, on more than that, and you can't put that in a digital twin. It does not mean that you can't apply this approach, but it means that each time you want to apply it, you have to request the help of the experts and to have them share what would have been their decisions if they were in face of different types of forecasts. So it definitely makes things harder to do in those parameters.
No, I think that's a fair answer. You're absolutely right, because in inventory we often have fairly well-defined rules, and those rules can be coded, of course, as you say, in a digital twin. In some of these other areas, it will be more difficult. Okay, well, so my next question is, if we just focus in on inventory for the moment, then, because that's a little bit more structured than some of the other areas. Even in inventory, it's not always straightforward to quantify costs. I'm thinking particularly about situations where we have inadequate stock and therefore don't satisfy our customers. Now, obviously, you can just go on straight loss sales, but of course, there's indirect costs as well. Things like loss of goodwill, for example, loss of future business, things like this. And these are very difficult to quantify. I'm just wondering, how does your approach take into account the imprecision there? Because you showed us a very nice precise graph with 3 lines, piecewise linear, 3 lines, and if those numbers were exact, we'd be fine. But of course they're not.
Yeah, for sure. And it's kind of fun, I would say, because each time I'm discussing this topic with demand planners in multiple industries. I've discussed that in retail, in chemistry, in the chemical industry, in cosmetics for an FMCG company. And one of the very first questions is, how do we estimate our costs? And this challenge is not specific to the approach we just discussed. Whatever the approach, if at one stage we want to translate our metrics into economic impact, economic costs, we have to know kind of the cost we have to face. So definitely, it's really hard for some costs to evaluate their values. So we are in front of 3 paths, three different possibilities. First, we understand that it's really hard and that we will never be able to really precisely get those figures. And then because of that, we decide to basically discard the topic and just keep on doing the things the way we do it. The second one is, okay, this is a really important point. We have to know our cost structure. So let's engage a project, and when the project will give its results, we will start using this. But until then, we'll stick to our good old way of working. Unfortunately, this kind of project could be endless, really endless. And the last option is the middle point. It's okay, it's a critical need, so let's engage a project to really know our cost as precisely as possible. But in the meantime, let's start with educated assumptions about the costs, and let's start with that. When more precise data will be available, we will update our models accordingly, but let's start with that. And clearly, my advice is to implement the third option, to start with working with educated assumptions, with a simplified view on costs, rather than sticking to an approach that we know is wrong.
I know, absolutely agree. Yeah, no, you're absolutely right about that, and I think that's a fair comment that you make. I think, of course, one thing you can do is recognizing that they are imprecise, to look at various scenarios and sensitivity analysis to those rates, and then because you may end up with slightly different results. I was very interested in the slide. I don't know if it's possible to show it again, the one which shows the correlation between the accuracy and the decision cost. That was really interesting. Do you mind showing that again, Johann?
Yes, I'm coming back.
To share that?
Sure, I'm coming back on it. Here it is. It's on. That's
the one. Yeah, thank you. Really interesting, that slide. I've never seen a slide like that before. So I'm taking it that the decision costs are following that piecewise linear function that you've shown us. Is that right?
Can you repeat your question?
The decision costs,
yeah.
Do they follow the piecewise linear function, the 3 lines? Is that how it's worked out?
In our in this experiment, we even we didn't included the obsolescence, so it was a
okay. So just two lines. Okay.
Yeah.
All right. Okay. So that's okay. So that's how it's done. That's understood. I'd just be interested in your comments on this, because you've commented on the 25% at the at the most granular level. I found a couple of things interesting about this. One is that MAPE does badly right throughout the whole of the graph until in fact we get to the granular level, when it's just equally as bad as anything else. But the other thing is, if you go right to the other end, and I know that's not what you've been primarily looking at, but the global level, there the W MAPE, that's a weighted MAPE presumably.
Yeah.
That doesn't do quite so badly. I wouldn't say it's doing terrifically well, but it's not quite so bad. Do you have any explanation for what's going on here?
I primarily focus, as you said, on the item store level, so I didn't add a closer look to the other levels. The weighted map by design is designed to give a stronger weight on perimeters where there are more volume or more value, etc. And I think that oh, sorry, my English is imperfect. My ideas don't come into English, you know. The example we showed, where we show the relationship between the piecewise curve, when you aggregate to a lot of skews together, it really averages that and compensate for this kind of elements. So at the end, it's a bit better. But clearly, I did not spend a lot of time trying to understand that. Sorry.
No, that's absolutely fine. No, please do.
And what would be your point of view? What would be your point of view on this?
I honestly don't know, and that's why I asked you the question. I don't know. Okay. I mean, I just found it a very interesting graph, Johann, because I've not seen anybody present correlation between accuracy and costs in that way, where you've got the different levels of aggregation. I found it a very interesting graph, and I don't know, honestly, I don't know the answer to that. It's definitely something we would need to give further thought to that. Okay, one more question for me, which is a more practical one. Obviously, setting up digital twins and so on, yes, can see the logic of it, but it is quite time consuming. From a practical point of view, for those people who are in practice here, are there any shortcuts they can take? Are there any ways they can get at the sort of thing that you're wanting, but maybe without going down the whole road of a digital twin?
There might be, as I said, the digital twin is at least one solution, might not be the best one, the simplest one, and I definitely hope that might be even faster ways to get to the point. It's not that time consuming, I would start to say. Really, for the example here, for the for the experimentation we made, so we implemented this. We did not compute all the costs by hand for the 74 different forecasts and so on, and really it was not that hard to automate such kind of approach to get things done by the computer. It definitely takes time to analyze the results and to really decide what the kind of decisions we could get from that. But on the balance, we should also account for the fact that it will help increase our efficiency in doing other parts of our job. We stop wasting time on perimeters that does not deserve it, and will generate more value in lesser time. So I mean, just to advocate for the digital twin, we have to have this full view on the additional work, but also the savings that could be done. This being said, I know that last summer, Ivan had a student from Lancaster University, even, who wrote a thesis on this topic. He started with one of the articles I published, and he analyzed the correlation with various business KPIs, but very common ones, such as service level, on time in full, and these kind of things. And if I'm right, he got very interesting results and some metrics that started to be well well correlated with the accuracy. Yet it did not give any clue about how to transform that into a monetized value. Those are KPIs that companies are quite often using. So if an easy correlation is found, it could really help practitioners start embracing this kind of approach.
Okay, well, thanks again, Johann, both for the presentation and for answering my questions. I think I'll hand back to Ivan, so an opportunity for other people to ask questions or make comments as well.
Thanks, John, for your comments. So I see that Robert has a question. So Robert, over to you, and then we will move to the audience questions.
It's more a comment. I mean, in organizational terms, the demand planners and forecasters are often really quite removed from the inventory, stock, ordering, logistics, the various functions which are the decision-making functions. And I thought about this question donkeys years ago and retreated from it, really because of the difficulties of generically structuring a cost system or a cost profit system to draw the sorts of conclusions you've done. I mean, it's not that I disagree at all with the thrust of what you're saying, but rather to say that despite it being suboptimal, it's best surely to see the forecasting function, and I'm including the uncertainty around the forecasting or the distribution around the forecasting, as well as organizationally separate, but also intellectually separate from the decision-making aspects of it, be it logistics. And in fact, I published a paper in Jaws, I think you might have had a hand in it sometime, John, essentially showing that forecasting was rather more important than some clever optimization rules. I wouldn't say that was general. I was rather arguing against the emphasis on the optimization without taking into account forecast uncertainty. So I wholly agree with the conclusion you draw, but I think it's but if it's a general conclusion to be aware of this issue, and Sven has a comment which may be in the discussion which relates to that, about what the nature of the weighted MAP is, what sort of costs are involved with that. So I guess I'm a yes but person here. I think having a digital twin, maybe a simplified digital twin, is a route forward, but I think it's the reason. Well, I won't say it hasn't been done. There have been one or two publications which have tried to do it, but they come up with often banal conclusions like bias is more important than accuracy. Well, yeah, sure. I mean, if you don't get the numbers right, bias is pretty important in terms of making any decision. So you've got to. It's not. It's not straightforward. The conclusion is not straightforward. The warning is surely correct.
Okay. Thanks a lot. I definitely agree, but I think that a part of that the fact that we have that in companies the way it's organized, the demand planners are separate from the people making the decisions, are two separate, almost separate populations, is an issue. At least when it comes to this kind of forecasts, which are really operational and starts to be automated in companies. And it makes sense to separate the organization in such a way, because forecasting requires really specific skills, and we need experts. But doing that, we kind of introduce a fracture in the company and an intermediate artifact, which is the forecast accuracy. And even though we are already doing great jobs with forecast accuracy, it's still a suboptimal, it's not perfectly aligned with the kind of forecast that would be required for this specific use. I think it's part of the reasons of this possible improvements.
Okay, Thanks. So we have several questions from the audience. I will actually start from the aforementioned comment by Sven, and he has a huge comment, but I will just extract the main thing from there. So I assume that you calculated weighted MAPE using volume, so divided by mean value. What about division by costs? Would that be different? What do you think?
It would have been different for sure, because by definition we won't use the same data. But I think the conclusions will still be the same, because the main reason of this poor correlation is the fact that forecast accuracy metrics are symmetrical, and costs are not. And according to my view on it, my humble view on it, is that the main reason for this poor correlation is that we switch from, when we improve our forecast accuracy, we sometimes turn from one side to the other, and costs don't follow as we would have dreamed them to or expected them to.
Yeah, that's an interesting point that you make in the presentation, that the costs are typically asymmetric, while when we measure the accuracy, we think that, well, the accuracy is symmetric. So it's an interesting implications. Juan just provided a comment that another important area of application of forecasting is, for example, energy. And this could be terribly nonlinear given the costs there, so that could be another potential area of application. So this is just a comment, not a question.
In one in your previous forecast for Friday talk, there was this presentation of the forecasting the energy market, and it was really interesting, and I highly recommend giving it an ear at some point, because it was really different to what we are used to.
Yes. Thanks for advertising our talks. Now there was a couple of technical questions. One about decision costs that you've shown on the slides. Maybe you can actually say briefly what is included in that, how it is calculated.
Yes. So generally, there are three categories of cost, at least in inventory management. The cost of being short of products. So as I said, that's for me the most difficult kind of cost to estimate. Then there's a holding cost, which is all about the cost of warehousing the goods, or insurance and cost of capital, etc. for the holding cost. And then the third kind is the fixed costs, all the costs. Each time you order to your supplier, you have to pay for some costs, operational costs, for really the workload, the people in the warehouse that will deal with that order, but also sometimes for the transaction itself. So we as I said, we discarded we included all of them in the three kind of costs in our experiment, and but a simplified view on them for sure. And for example, when it comes to shortage costs, usually when we face a shortage, we have as a customer, we have three choices. We can go for a substitute, we can just delay our purchase, or we can just leave and go to another store, or just abandon our transaction. Here on our example, we included some proportion of substitution. So people could, given we are in a retail area, in a store, you can turn to, there's a very wide variety of products in front of us. So we can easily substitute one product that is short by another. So we take the assumption that 50% of the sales would have been substituted, and the other sales would have been lost. But for sure, those figures does not come from a specific benchmark and so on. They could have been more educated, definitely with more education, but it was not the case.
Okay, yeah, thanks. I have actually a related question. In your posts on LinkedIn, you define several costs. You call them DIA, DIN, DIO. So in that case, you're developing a measure that summarizes performance in terms of costs. Do you assume that the forecast is used directly for replenishment as you actually did in this presentation? Is that the idea?
No. In the experiment, it was way more realistic in terms of policy. We implemented the just let me come back. I put some notes. The dynamic order up to policy. So it was more realistic policy. We conducted different experiments. Some experiments with inventory already in place, or with in progress deliveries, or these kind of things, to be closer to the reality, and other experiments without any inventory, so just as if we were sending it the product for the first time. All the publications so far have been made on this second part, so no inventory at first in the warehouse, because we really wanted to compare the forecast accuracy of all the products together. I mean, with the same importance. If a product was already stocked, and if there was no further needs, we wouldn't have replenished, and then it would have added a bias in the analysis. So the analysis was conducted without initial inventory in stores, but we have very interesting insights about the kind of decisions that could be made where inventory is already in place.
And this aligns with the question of Sven, another question in the comments, who asks, when you did this digital twin measure, did you apply it to safety stock?
Yeah.
Because it makes sense. Yeah, okay, safety stock it is.
We applied safety stocks with 95% target level, service level.
Right, okay, thanks a lot. Thank you, Johann, for a great presentation. Thanks, John and Robert, for your comments. And thanks, everyone, for coming and attending this session. And have a good weekend, and see you all in 2 weeks.
Thank you, John, Robert, and
Great,
Ivan.
very interesting. Thank you.
Thank you very much.